Hi everyone, welcome to this video on straight line graphs from equations. So what we're going to do in this video is we're going to look at when we have an equation of a straight line like this, which we've looked briefly at before, how do we draw that out as a straight line on a coordinate diagram, okay? So let's look at an example, right? So we plot the line with equation y equals 2x plus 1 on a Cartesian coordinate system. Now, what is a Cartesian coordinate system? Well, that's just basically your y and x axis, okay? So that's a name for that, it's a Cartesian coordinate system, alright? So, how we do this is we always start off with the same table. No matter what the equation is, we always start with this table here. So we've got x values which we've picked, 0, 1, 2 and 3. Why do we pick those? Because they're easy. Okay, and then we're going to find out the y values that correspond to those x values. Now, how do we do that? We're going to do it by substitution. Alright, so if we know that y equals 2x plus 1, then if x equals 0, y equals 2 times 0 plus 1. 2 times 0 is 0, so that's going to be 1. So when x equals 0, y has got to equal 1. Because remember, the equation y equals 2x plus 1, that relates the x and y values for that line. Okay? So, if we have x equals 1 this time, we substitute that in. So y equals 2 times whatever x is, plus 1. So 2 times 1 is 2, plus 1 is 3. So then, if x equals 1, y equals 3. So you can see that as you change the x value, the y value changes as well. And all the y is, remember, is it's 2x plus 1. So that means we take the x value, times it by 2, and add 1. So it's a really simple formula, okay? But we've just got to work out what the y values are in each case. So we move on. Y equals 2. So we sub in 2. So y equals 2 times 2, add 1, which is 5. Then we put our value in. We might actually be able to see a pattern arising here, okay? If you can see that, that's really good. But we should still go and prove what y equals for x is 3 as well, in case it's not going to be what we expect it to be. So 2 times 3 add 1 is 7. That's what we should have expected there. Okay, so now we've got a table of values. And that table of values gives us an x coordinate and a y coordinate for 4 different points. And what we can do now is we can use those points to plot out our graph, and we'll see what our graph would look like. So we'll see what y equals 2x plus 1 looks like actually on a y and an x axis. Okay? What we want to do before that is, this is just to stop us making wee mistakes. I found that this helps a little bit. So if we write down the coordinate underneath, so that's going to be 0, 1, and then 1, 3, and then 2, 5. Remember, the x coordinate goes first, and the only reason I'm doing this is to stop you mixing them up. So I want you to be very conscious of what you're actually doing here, because a lot of times if you just leave it as a table, then sometimes people mix the values up and go like 1, 0 instead of 0, 1 and so on. Okay, so if you actually write it down each time underneath, all we're doing is we're taking the values 0, 1, 1, 3, see, it's really simple, and we're writing them down so that we're focusing on these points when we plot onto our graph. Alright, so onto the graph, right? So we've got our Cartesian diagram drawn here, alright? So our first coordinate was 0, 1, so that's going to be here. And then we've got 1, 3, and 2, 5, and 3, 7. Excellent, so they make a straight line, we can see that. If we had one coordinate that was maybe over here, right, and we don't draw like that, it should make a straight line, okay? So that coordinate, maybe we made a wee mistake in the calculation, so we want to go back and look at that one again. Right, so we'll put that back in its right place, so that was 2, 5. So if you make a mistake, it kind of catches itself. That's why we use 4 points, because 4 points allow you to make a wee mistake here and there, and be able to catch that mistake, okay? So after we've got our 4 points in a row, we just take a ruler, and we draw a straight line through these. Try and make it as accurate as you can. Okay, so we can see that's just a wee bit off. It's quite hard to do it on a vertical surface. So, and you can see that what I've done there is I've drawn the line either side of the maximum amount of points we've picked as well, because you should really extrapolate the line, because in theory this line actually goes on infinitely in that direction, then infinitely in that direction, and that's what you're actually showing when you do that. That's called extrapolation. So if you extrapolate the line beyond the points you've drawn, then that's good mathematical practice. Okay, so I'm just going to go through that one again, and obviously you can rewind me and look over it again. We'll just go through it quickly one last time. Okay, so we have been asked to plot the line with equation 2x plus 1 on a Cartesian coordinate system. We start off with a table. I've told you to use the values x is 0, 1, 2 and 3 because they're nice and easy. You can of course pick any values you like, but I think it's easiest to start with those ones. Then you work out your y values that correspond to that using your formula. So you just substitute in 0 for x first of all, then 1, then 2, then 3, and see what you get. You can see I've done this here. So remember, set out your working for each one to get the values, put your values into the table, make them into coordinates, and then you plot your coordinates on your Cartesian coordinate system, and then you must remember to actually name your line, because we're going to look next at when we've got 2 or more lines on the one diagram, so it's really important that you actually name your line as well. Alright, so that's how we do plotting a line from an equation onto an actual graph, a Cartesian coordinate system, so remember that for next day. Okay, and we'll see you next time.